All righty, it's 10 o'clock. Good morning. Thank you for joining us for our first copy break series of 2021. Welcome back, everybody. Today we're going to be talking about displacement induction ventilation. I've got Einar Frobaum from Carson Solutions with me today, and we're going to discuss this for K-12 or any classroom environment. With that, I'll turn over to Einar. Thank you.
Thanks, John. As John mentioned, my name is Einar Frobaum. I'm the Director of Sales and Marketing for Carson Solutions. And Carson Solutions is a manufacturer of cabinet diffusers utilizing a strategic approach called displacement induction ventilation. And we've been delivering that technology for nearly 15 years to nearly 500 US schools, with nearly 1 million students being positively impacted due to our approach. So we are going to be stepping through a fair amount of info in a short period of time, but there's 5 key items I want you to take away, which is what type of mechanical system is this applied, understanding the differences between ventilation versus a mixed air system, how does the QLCI diffuser work, what are the benefits of applying this for classrooms, and where is this technology applied, although I may have stepped on that punchline already. So when I've talked with school districts over my years, here are a number of items that they've said are important to us, and certainly air quality is probably at the top of the list today. Acoustics, thermal comfort, kids are hard in classrooms. We've got high visibility. We've got increasing budget requirements with reducing budget operating budgets, and we've got a lot of issues that we need are important to us, and if they're important to them, they should be important to us as we step through the designs for these environments. At the crux of these designs is that they're densely populated spaces. So in order to address that, we need to bring in the right amount of outside air at the right level, because if we don't, we start dealing with issues like how do we remove contaminants, or do we bring in the aspects of allergies, mold, and ultimately sick kids and sick buildings. So one way to ensure that we deliver the right amount of outside air is to apply a dedicated outside air system. We can deliver a known quantifiable amount of outside air in a typical arrangement, as I show on the screen, fresh air to the space, and now you have the fan coils serving as the terminal unit, addressing and churning that room and addressing those sensible loads within that space. Conversely, all we're doing is changing out in our application, taking out that fan coil and implementing the QLCI diffuser. Same amount of fresh outside air delivered directly, but then how that air is delivered to the room, how it moves through the room, and ultimately exhausted is going to be the difference and the benefits of applying the system. So key bullet point number 1, what type of system is it typically applied? It's a DOAS unit, a chiller, a boiler, and a terminal device. As an option, and I've seen it applied several times, this could be tied to a geothermal system as well. So the goal of ventilation design is to have your classroom IAQ mimic that of the fresh outdoor air. So key bullet point number 2 related to that is let's talk about the differences between mixed air versus displacement. Here's a smoke video from our lab showing high velocity air being delivered high in the ceiling diffuser. This is a mixed air system. It's churning the room. You can see it's suppressing contaminants. The goal of a mixed air system is to create a uniform environment, floor to ceiling, both in temperature as well as contaminant. Conversely, if you look at displacement, usually the diffuser is located in the zone, and when the air comes out of the diffuser, it's slightly cooler than the room air. It migrates across the floor until it comes in contact with the occupant. And when we add heat, we create this thermal plume that comes up our bodies, and the benefits are we deliver the fresh air, 1, immediately to our breathing zone, but 2, that thermal plume continues upward. And so when we expel contaminants, those contaminants go up into the unoccupied and away from us, not sharing those contaminants with our neighbors. Here's that same lab with the smoke coming out of the QLCI, low velocity air migrating into the room. And now one of these weird creepy mannequins is heated. It is the center one, and you can see that effect of heated conditions delivering fresh air to our breathing zone and then taking those contaminants up and away. Here's a comment from the EPA for their IAQ for schools. If you click on this web link under types of air distribution, that even though schools mostly are designed with mixed air systems, highlight yellow. Designers should investigate a method called displacement. This approach successfully uses natural convection and, more importantly, reduces fan energy and lifts contaminants up and away from the breathing zone. Very powerful comment from an entity like the EPA. Key bullet point number 3, how does it work? So the physical arrangement of a QLCI is 13 inches in depth, 30 inches in height, and then the length varies from 4 feet on up to 8 feet. And usually there's 3 or 4 of these QLCIs lined up on the exterior wall of the room. The driving force of the QLCI is going to be your 100% outside air delivered to this plenum. And at the bottom of this plenum is a series of nozzles that create a low pressure area as the air exits the nozzles, which induces 2 parts room air across this hydronic coil. That hydronic coil is tied to hot water or chilled water loop, which is going to preheat or pre-cool that room air. And then those air streams are going to mix. And then you're going to have low velocity, uniform distribution of supply air out to the space. Notice I didn't say anything about fans, motors, compressors, dampers, or even filters. I don't have any additional sound generating sources, which allows this particular terminal device to deliver 35 dBA or lower background noise for a classroom environment. I've got a comment there on high ventilation effectiveness. It's greater than 1.2. We'll talk a little bit more about that as we step through ventilation effectiveness in a couple slides. Cooling mode. So when we go into cooling mode, you're going to have your fresh outside air at roughly 53, 55 degrees delivered to the plenum, induce 2 parts room air. This chilled water coil at the time, it is 1 coil, but it will be fed with 55, 60 degree warmer water. And then that airstream is going to go out into the space at about 1200 to 1300 CFM, come in contact with the occupants, and then ultimately a third of that will be exhausted to keep the system balanced. Heating mode. One of the biggest challenges when you're dealing with displacement is heating. Usually you have to add a separate system like fin tube radiation. However, our design allows for, I'll step through it. We warm the DOAS air up a little bit. We bring that into the plenum, induce the same 2 parts room air. The hot water being delivered to that same coil is going to be 120 to 140 typically. But instead of delivering high grade heat, we're going to take advantage of the occupants that are in the room and deliver just the right amount of heat, which tends to be low grade heat, because low grade heat wants to go out and not go up and still maintain and satisfy the thermostat, but also ultimately recognize that stratified or displacement operation as it goes out into the room. I'm in Minnesota and you guys are in Colorado. And so when these are lined up underneath the window, we're going to have a cold draft drop. So this adds to the thermal comfort because that cold draft doesn't go out into the room. It actually gets sucked in and gets preheated or retreated before it goes out into the space. Energy efficiency. I mentioned vertical or ventilation effectiveness. If you look in 62-1, you'll find a table that delineates between well-mixed systems and stratified systems. So I wish they would have termed it contaminant removal effectiveness, because that's really what ventilation effectiveness is. It's a measure of the contaminant level at the breathing zone compared to the contaminant level at the exhaust and the supply. So the best a mixed air system can do is 1, meaning contaminant level here at my breathing zone is the same as it is at the exhaust, versus a stratified system, which is going to be greater than unity, which means that the contaminant level where I'm standing is going to be fresher than it is at the exhaust. And here's how that comes into play for air transportation efficiency. If you look at that's a single classroom and you're comparing it to a mixed air system and a displacement system, if you do the calculation on the number of students and the size of the room, you're going to divide by the ventilation effectiveness. And so a mixed air system, in this example, is 408 CFM of code required minimum OA to the space. If you look at displacement, because I'm dividing by something greater than 1, I'm actually able to reduce the amount of code minimum outside air. So I'm impacting not just the room, but also the DOAS sizing, as well as your supply and exhaust air ductwork as well. Here's a real world example of that scenario. Building designed in Minnesota, it was actually tied to a geothermal system. They had displacement systems in the classrooms. It was LEED certified, and when they measured it out, it was 64% more efficient than the benchmark at the time. School district, we love it, duplicate that building, don't change anything, but they did. They actually went from our displacement systems to overhead chilled beams, which are very similar, but because they went from displacement to overhead, a mixed air system, they actually lost 20 percentage points, which is a huge deal to the people that are paying the bills. Maximizing floor space tied to thermal comfort. Because of the warmer temperatures and because of the low velocity, these school districts are able to actually maximize their floor space by putting desks right up against the diffusers. These are examples of the districts arranging these rooms. If they took complaints from the students, they wouldn't leave these rooms configured as such. Here's an example over on the right where the student actually pushed their desk up against the QLCI to maximize their desk space. Acoustics. Acoustics cannot be overstated. As an example, the number of challenged learners and the number of learners where English is not their base language is ever increasing. So the quieter, the less distractions we can afford them, the quieter the environment, the better engagement we'll receive and better learning and teaching environments we'll create. Here's a real world example again. Mixed air system where one room was being served with a unit vent and right next door was one being served with a DOAS unit and displacement. There was 20 dB difference between those background noises and those rooms. Considerable for sure. Maintenance, saving operating budgets for these school districts. The maintenance aspect of the QLCI in the space is extremely minimal. You take that front panel off, you expose that hydronic coil, and you vacuum it off once a year. There aren't any motors, dampers, compressors to change out. There aren't filters to change out. Any maintenance associated with this system is outside of the room, so you're not distracting the learning environment as well. Construction, the kids are demanding on the equipment. They will jump on it, for sure. These casings are designed to withstand a 250-pound point load. They're coated with a high-grade powder coat finish. It's textured, it has a matte finish, so to help prevent fingerprint pickup. It's attached to the wall, so it's a safety mechanism. It has an integral toe kick at the bottom to allow for maintenance ease. And even though we do design these to run dry, every coil does have a drain pan underneath it. There's a number of design options that you can implement. In this example, in the upper left-hand corner, this particular school wanted the QLCIs recessed and not protruding out in the room. Here's an example of a custom laminate solid surface countertop. We can get laminate countertops as well to help dress these units up. We have a number of custom and standard bookshelves and other cabinet pieces that can be arranged to give that full wall arrangement, and then standard custom colors to meet your needs as well. So this system, it's not just the QLCI by itself, but applying a DOAS-based system helps deliver mandated outside air using displacement for better IAQ, better thermal comfort, decreased maintenance, better return on investment. All these things check the boxes that were important to these school districts. And even though the system can be and is applied in both new construction and renovation, here's the home run application or the shortest cut, whichever cliche you want to use. If you have a school that's full of aging unit ventilators, take advantage of the utilities that are already in place. Let's help maintain that school district, the cabinet bookshelf look and functionality, We can eliminate noise, maintenance needs, the concerns about covering the vents with books and understanding why they have thermal discomfort issues. We're going to save on utility bills because it is more efficient. And more importantly, in today's environment, we're going to deliver verifiable, quantifiable outside air that's so critical to these school spaces. So better ventilation design affords better learning engagement and better absentee rates, because when classroom indoor air quality does mimic fresh outdoor air, classrooms are healthier and safer, just like studying at home. So for more information, please, or a dedicated presentation, please contact your local Long salesperson or visit carsonsolutions.com or long.com. And I'll turn that back over to John.
Thanks again, Ana. I really appreciate your time this morning. I appreciate everybody joining us. And if you could, Ana, move over to that last slide. That just gives us we're doing a little giveaway this morning.
There you go.
We have raffle prizes of an REI $100 gift card, Coach purse, or a Justin Timberlake pillowcase. Again, thank you for joining us. And next week's presentation is going to be by Cutter Ballant. It's going to be about BAS analytics. So make sure and join us on the 14th at 10 a.m. And thanks again for your time this morning.